Hi everyone, I'm Liz Walls, lead developer of the Continuum Wind Energy software and director of renewable energy services at the One Power Company. And today I'll be showing how to generate wind speed and gross energy estimates at wind turbine locations in Continuum. Okay, so to do this, you'll need to first specify where the turbine sites are, and you'll need to generate a wind flow model in Continuum. Now there are a few input files that you will need, which includes topography data, land cover data, met site data, and the turbine site coordinates. So first, let's discuss the turbine site coordinates. These are imported into Continuum as a CSV file containing the turbine name, latitude, and longitude, and there should be no header in this file. So once you have that defined, you'll want to open Continuum, save the file, and then click Import under the turbine sites. Next, let's talk about met site data. Now this may be imported into Continuum in two different formats, either as a tab file or as a time series file. A tab file contains the wind speed and wind direction joint probability distribution at a specified height at the met site, and it does not contain any temporal information. A time series file, on the other hand, contains the wind speed and wind direction as well as other sensor measurements as a time series. For this tutorial, we'll use tab files. So to bring those in, you want to click Import Tab Files, navigate to where those are, and then you can select all of the METs that you want to include in that wind flow model creation. Select Open, and it will bring the MET sites in. Next is the topography data, and this may be imported as either a GeoTIFF or as an ADF file. If needed, topography data may be downloaded through Continuum by clicking Tools, Download Topography Data. So this accesses the Open Topography API, which requires registration at this URL. Once you do that though, you'll enter in your API key, select from the datasets that are available, and then enter in the range of latitude and longitude that you want to download. It is really important to note that for the wind flow model in Continuum, you need a minimum buffer of 12 kilometers around all met sites and turbine locations. So to make your life a little easier, when you open up this download topography form, you'll see at the bottom here a button that says Find Bounding Box around METs and turbines, and by default it uses a 15 kilometers for a buffer. I like to use something a little bigger than 12 just in case we add more MET towers or more turbine sites down the road. So by changing this value, you can update the lat and long that covers that bounding box. So once you have that defined, you click Submit, and then it will download a GeoTIFF file for you. Once that's been downloaded, you just click Import Elevation Data, find that topography data, and click Open. And then it will read in the topography data and save it to a local database file. Once the topography has been read in, then the input file will update and will show the MET tower locations as the black dots as well as the turbine locations. And then the heat map shows the elevation contours of the topography data that you've uploaded. And next is the land cover data. And this may be imported either as a GeoTIFF file containing land cover codes or as a .map file which contains roughness contours. If you import land cover codes, then you can select from one of the built-in land cover keys, or you can import your own by clicking Import Key. The land cover key assigns surface roughness and displacement height to each land cover code. If you have a .map file with roughness contours, then Continuum will automatically create a land cover key and will assign a displacement height to each roughness category. But these may be modified by selecting any of the land cover keys or land cover categories, clicking Modify, and then you can manually change and set the surface roughness and displacement height for each land cover type. So once you have your land cover key either imported or selected, you click OK, and then click the button Import Land Cover Data. For this tutorial, we're going to use a GeoTIFF for input, which is right here, Land Cover Data. We'll click Open, and then it will also be read in and saved to the local database file. And after the land cover data has been read in, then you'll be able to select this drop down at the bottom where you can take a look at the land cover data that's been imported, as well as the estimated surface roughness and displacement height in each gridded spot. So now that all the necessary input files have been imported, the next thing to do is to create that wind flow model. So all we have to do on the Input tab is click the button Analyze METs. And it will kick off the calculations where Continuum will automatically generate a wind flow model, which uses all the MET-site data that we've imported, along with the topography and land cover data, and it uses a machine learning algorithm to find the wind flow model coefficients that yield the lowest MET cross prediction error. Once that is done, then we'll move on to generating the estimates at the turbine sites. Once the wind flow model has finished, then you can click the button Generate Wind Speed Estimates at the turbine sites. And this will kick off the calculations at the turbine sites, including calculating the terrain complexity, as well as the terrain exposure, surface roughness, and displacement height at each site, and then finally estimating the wind speed at each turbine location using that site-calibrated wind flow model that we've just created and using each MET tower as a predictor. You'll notice that the Create Time Series checkbox is grayed out right now. And the reason for that is because we're modeling using tab files, which, as you'll recall, do not contain any temporal information, right? They just contain the wind speed and wind direction probability distribution. So we will cover how to generate time series estimates at the turbine locations in a new video. Once the wind speeds have been calculated at all the turbine sites, this button will turn green, and then you can go to the Gross Turbine Estimates tab to check out the results. This is also where you can import one or more power curves. Power curves are imported into Continuum as a CSV file, where the first row contains the name of the turbine model, and then you have 3 columns, the first one for wind speed, second for the power output, and the third for the thrust coefficient. Please keep in mind that the wind speed in the power curve file represents the midpoint of the bin, as opposed to tab files where the wind speed represents the maximum value of the bin. So then to bring it into Continuum, just click the button Import Power Curve, select the one you want to bring in, and click Open. It'll ask you for the rotor diameter of the turbine as well as the RPM, which is usually around 15 or 16 for large modern wind turbines, and click OK. Once the power curve has been read in, then you can click the button Generate Gross Energy Estimates at the turbine sites, and this will calculate the energy production at the turbine sites using the power curve that we've imported. Once the energy estimates have been calculated at the turbine sites, this table will populate, which will show at each turbine location the elevation, the wind speed, the annual energy production, the capacity factor, as well as the Weibull shape and scale factor. Now, as I mentioned, you can import more than one power curve and then toggle back and forth between the two to view the different energy estimates. So you just click Import Power Curve again, click the second one that you want to bring in, answer similar questions about the rotor diameter and RPM, click OK, and then it will calculate energy estimates using that second power curve. You may view the overall estimates, or you can toggle through the different wind direction sectors to view the sector-wise estimates. The wind speed and wind rows distributions can be viewed in the top right, and you can toggle between the wind speed distributions and the wind rows by changing this drop-down. So there's the estimated wind rows at the MET sites and turbines. Down in the bottom left, we have some statistics at the turbine site, so the average, standard deviation, min-max of the wind speed as well as the energy production. And then we have a histogram of parameters measured at the turbine and MET sites. So you can look at the wind speed, gross energy, elevation, or the Weibull parameters and see how the distribution at the MET and turbine sites look. And lastly, we have some export functions on the Gross Turbine Estimates tab. We have 4 buttons at the top here. So the first one lets you export the overall wind speed, Weibull parameters, and energy estimates at each turbine location. The second one will provide you an export of the wind speed, the overall wind speed distributions at each turbine location. The third one gets into directional or sector-wise estimates. So if you click this third button, it will export a summary of the directional wind speed and Weibull parameters. And then lastly, the fourth one will export the directional or sector-wise wind speed distributions estimated at each turbine location. Okay, well, I think that covers how to generate gross wind speed and energy estimates at turbine locations in Continuum. We'll go over how to estimate losses and generate net energy estimates in a future video. I hope that this was a helpful tutorial. If there are any questions or comments, feel free to comment on this video or send us a message through the website contact form. Thanks for watching, everyone, and take care.